Hi everyone. In this video we're going to discuss how to graph exponential functions. An exponential function is found anytime your variable is in the exponent part of your equation. So if you had an example like 2 to the x, 3 to the x, because the x is in the exponent, that lets you know it's an exponential function. Now what I need you to memorize in order to be great at graphing these is anytime your a is greater than 1, an example could be like y equals 2 to the x, y equals to 10 to the x. Because this a, your base, is greater than 1, your graph is going to end up looking like this. And what this is considered is an exponential growth. So anytime your a is greater than 1, you have an exponential growth, and that's because your graph is going up, meaning it's growing. And anytime you have an equation where your a is between 0 to 1, what I consider it as like a fraction, you're going to have an exponential decay. An example of that could be y equals to 1/4 x, y equals to 1/3 x. Because it's between 0 to 1, like again I said, because it's a fraction, it lets you know that it's going to be an exponential decay. Alright, so once you know that, we can actually go ahead and start graphing them. Now we have 3 different examples that we're going to end up graphing. One of them is going to be a basic one, and then the next are going to have different transformations. Now, in the equation f of x equals 4 to the x, the most important rule in order to be able to graph these amazingly is you want to figure out the number that's being added or subtracted to this variable right here in the exponent part. So since there's no number being added or subtracted, I'm going to put an imaginary plus 0 because technically there's a 0 there. Now it's important because what you're going to do is, in order to be great at graphing, you need to take the opposite of that number that's being added, subtracted next to x. And the opposite of 0 is just 0, so you're going to have to set up a value. Now you're going to put that number that's opposite of that in the middle. For example, 0. You're going to pick a number less than it and a number greater than it. -1 and 1. If you always pick the number that's opposite of that middle number in the exponent and put it in the middle and pick one less and one greater than, you're going to be right, and the numbers that you're going to work with are going to be easy. Now once you have this, we'll just plug it in. So when you plug in -1, you get 4 to -1. What you have to memorize is anytime you have 4 to a -1, meaning anything to -1 power, make this a fraction. The reason why you want to make this a fraction is because the negative exponent just flips this. So this becomes 1/4. So now -1, it's 1/4. Then plug in 0, f of 0, 4 to the 0, and anything to the 0 is always 1. And then lastly, plug in 1, and you're going to get 4 to the 1, which is just 4. Now if your teacher allows you to use a calculator, then just plug all these values into your calculator. Now once you have this, graph it. Graph all the points that are given to you. Our first point is at -1 1/4, so at -1, 1/4, 0 1, and at 1 4. Now because this a is greater than 1, I know it's an exponential growth, so I'm going to have a graph that looks exactly like this. Now there's a reason why I'm never crossing this x-axis, and that's because there's actually horizontal asymptotes in this graph. So what I want you to do is the number all the way on the right hand side that's by itself, that's plus or minus something. In this case there's no number, so there's an imaginary plus 0 there as well. Because there's a plus 0 on the outside, that is your horizontal asymptote. So what you need to make sure you do with the number all the way on the outside, you need to put a horizontal asymptote at 0 so that your graph can never cross this line. So the number on the outside tells you a horizontal asymptote, which you can't cross, and the number next to x, the opposite of this number, is where you're going to start off. Pick one number less, one number greater than, and then the points are going to be easy. Alright, so if you're able to do that, you're going to get these right every single time. So now we're going to look at a different example, something with a transformation. F of x equals 4 to the x plus 1. So once again, try to find your HA. Is there an HA? No, there's an imaginary plus 0. So you know your HA is at y equals 0. That's important to know because it can't cross that line. So now we have to set up our x and y table. Look at the number that's next to x in the exponent, +1. Pick the opposite of that. The opposite of that. Opposite of +1 is -1, so you're going to put -1 in the middle. Pick a number greater than that, -2. Pick a number less than and greater than 0. Now plug these values into your x. 4 to the negative 2 plus 1 will give you 4 to the negative 1, which once again, make this a fraction. Then when you make it a fraction, flip it. Anytime you have a negative exponent, flip the fraction. So you get 1 to the 4th. 1/4. Then plug in negative 1. Gives you 4 to the 0. What's 4 to the 0? 1. So there's a 1 there. And then plug in the last point, f of 0. 4 to the 0 plus 1 gives you 4 to the first, which just gives you 4. So then this gives you a 4. So if you pick the opposite of that number, all these values are going to be the same exact values. You're going to get negative 1, 0, and 1 every single time. Now once you have these values, we'll graph your function. Remember, there's a horizontal offset y equals 0. So you can never cross that line. Negative 2, 1/4. Negative 1, 1. And 0, 4. Now because 4 is a number that's greater than 1, it's an exponential growth, the reason why your graph is going up. And that's how you graph this function. Alright? Now the last one is something that is an exponential decay, but also you'll notice that this 2 is your HA. So you have a horizontal asymptote at y equals to 2. So then your next step, figure out the point that's opposite of the number that's next to x. You'll look at negative 2, opposite of that, 2. 1 less than, 1 greater than. Then your next step, just plug everything in. F of 1 is going to be 1/3, 1 minus 2. 1/3, 1 minus 2 will just give you 1/3 to negative 1. Now you have a fraction raised to a negative power, so what do you do to that? Flip it. Gives you 3. Now the one thing you can't forget to do is, you see how we circled that plus 2 because that's our HA? After you get these values, add a 2 to it because you can't forget about it. So this gives you 5. Then plug the next one, f of 2. 1/3, 2 minus 2 gives you 1/3 to the 0, which gives you 1. Don't forget about that plus 2. Add 2 to it, you get 3. Then lastly, plug in the 3. F of 3. You get 1/3, but then you have to add 2 to it. Now, if you have a calculator, plug it in. If not, get an LCD. LCD of 1/3 and 1 is going to be 3. So then this becomes a 3. This becomes 6. So that you get 7/3. 7/3, or something as 2.3. Now, once you get these values, you're going to graph all these points. Now don't forget that we said that there's a horizontal asymptote at 2. So that at 2, I'm going to put a horizontal asymptote because I know I cannot cross this line. Then my next step, graph all the points. At 1 it's 5. At 2 it's 3. And at 3 it's 1 and 1/3. And because your graph is less than 1, you know it's a decay, so your graph should be going down. And that's how you graph exponential functions. So what I want you to focus on, if you're able to figure out the point that's opposite of this, that's going to be your starting point. Pick 1 point less, 1 point greater than. The number all the way on the outside is going to be your horizontal asymptote, a line that you can never cross. And then once you plug in these points, just solve them. And then once you solve them, graph them, connect the dots, and you'll be done. Thanks for watching.